Okay, summary of base functions. First, I want to tell you about the functions that you're supposed to know by now. If you don't, then spend some time looking at the sheet and making sure that these functions, even if you had the shape down, even if you're like, you see one of these functions, you go, oh, I remember what that is going to be kind of shaped like. That'll be enough. Because if you get stuck with one, you can always build a table of values if you really needed to. But you really want to have a jump start on it by knowing what table of values to build based on your knowledge of the shape. You're supposed to know y equals x. That's supposed to be grade 9. Y equals x is the straight line. From there, you'd change the y-intercept and change the slope. We didn't call it transformations at that point, but that's all that was going on, is we were transforming this thing. Y equals x squared, grade 10 and grade 11. This got crazy, right? Y equals x squared got out of hand. You had to learn about factoring, quadratic formula, computing the square. This really went nuts compared to what went on in grade 9. So this went over into grade 11. Then in grade 11, here we go. Here may be the COVID thing here. Like 2 different semesters might have seen different amounts of this stuff. You're supposed to have seen y equals root x, which is a sideways parabola, but you only get the top half because it's a function. You don't get both halves of this thing. You only get the top half. Y equals root x. Did you see y equals root x before? Not hard to build a table of values for this. And if any of these functions on the list, you're like, I don't really know that one all that well. Take a minute and build a table of values for it. It's surprising how much you learn from a table of values, just plugging in a bunch of x values and going, oh, I see what's going on here. 1 over x. You see 1 over x in grade 11? All right. Again, I say go home tonight and build a table of values for this thing. Take you about 5 minutes, and you really get to know why this function looks like it does. The important things are, for very large x values, the y values just keep getting smaller and smaller. Think of it this way. 1 over 2 is like 0.5. 1 over 3 is like 0.333. 1 over 4 is like 0.25. 1 over 10 is like 0.1, and it just keeps getting smaller and smaller from there. You go this way, you can't have 0. That's how this function handles that. You can think of it that way. You can't divide by 0, and what happens? The function just avoids 0 like this. Why does it take off like this? Very weird. I'm going to calculate on the screen and show you. We'll put in x values close to 0. Where's my calculators? Incidentally, if you want to give your calculator the advanced functions test and see if it's going to be a good calculator for advanced functions, just type in a line something like this, 5 plus 3 divided by 2, something like that. If you can see all the numbers on the screen by the time you type a couple operations, your calculator will be all right. There's still old calculators around where you go 5 plus 3, and all you can see on the screen now is the 3. No good. You're just going to die in chapter 2 trying to use a calculator like that. You're not sure? Call me over. Anyways, watch this. I'm going to go 1 divided by a pretty small number, 0.1. And I get the number 10, which mystifies people. You're like, 1 divided by 0.1, how can it be 10? Well, I've taken a dollar and I've divided it into dimes. How many dimes in a dollar? 10. That's why the number gets big. If you're dividing by very small pieces, you get a very big number. Let's do it with pennies. 1 divided by 0.01, you get 100 pennies. There's 100 single cents in a dollar. So it makes sense. If you're dividing by something less than 1, you'll get big numbers. And that's why that function does what it does. Let me go 1 divided by 0.0001, something really small. Now we're up to 1,000. And as you divide by things that are closer and closer to 0, you get a bigger and bigger number. And that's what's happening here. As we divide by numbers that are close to 0, we get really large numbers. And then the negative side just does the same things, just it does it with negative numbers, that's all. Not sure about this one? Build a table of values tonight. Get to know it, because it's a function you really want to know its shape as we move forward here. Exponential functions. So you biology people, if you're heading down the biology path, your life is exponential functions, exponential growth. And this function here is why coronavirus is so dangerous right there. It can double very quickly, and then, it's like what the cases did between now and August. 100, oh, that's bad. Oh, 200, oh, that's really bad. Oh, 600, 1,200, whoops. And it can get out of hand. If it keeps doing what it's doing, folks, we'll be throwing case numbers like 5,000 and 6,000 within a week or so. No problem. That's no big deal for coronavirus. It can do that. That's why they should be panicking, and they're not panicking enough. Oh, and look at this guy. New friend. Y equals absolute value. Yeah? Again, if this one's mysterious to you, if you didn't see enough of it in grade 11, sit down, make your table values from -5 to 5, just plug the numbers in, and you'll totally see the behavior. You'll go, oh, I get what it's doing and why it's doing it. Table values, great power here. Sine and cos. Again, you're supposed to have seen that in grade 11, but if you didn't, don't panic about these ones at all. Okay? Unit 6 in advanced functions is called trig. Trigonometry. We do trigonometry part 1, trigonometry part 2. I promise to you, I won't put any trig stuff on tests until we do the trig chapter. Yes? Will it be in the homework? Sure. Anytime there's a trig one in the homework, just graph it using Desmos so you can answer the question. Refamiliarize yourself with it, but don't get all stressed about it yet. We'll get enough stress out of trig later. Okay? So, what are you restricted to? 1, 2, 3, 4, 5, 6 functions that you should know the shape of them when you want to go to graph them. If we look forward to the, if you look on the chapter on D2L, I've already posted the practice test for this chapter all the way down there. Sample test, I call it here. And you'll see on the sample test, I opened up with, okay, I started with a parabola, say, here, just graph this thing. Show me you know how to graph this thing. That's one of the base functions, y equals x squared with some transformations on it. I'll do more transformations tomorrow. Then I chose absolute value. Of course I did. New to you this year. And said, here's some crazy transformations. Show me you can graph this thing. Don't freak out yet. The transformation lesson is tomorrow. Now, we haven't really talked about that too much. But the important thing I want to get to is that you need to know those base functions. You need to know the shapes of those 6 base functions that we talked about. That reference sheet is in your notes, so you got it to look back on when you're doing homework. That's not really today's, this afternoon's lesson. Here is this afternoon's lesson. If you flip to the next page, I think you'll see this. There's not much room to write on this one. After the original PowerPoint, if you flip ahead, you'll see some worksheets, and we'll use those whenever we need space to write things. So we'll have to talk back and forth as we go through this. Up to this point, you've worked with several parent functions, also called base functions. A parent function simply refers to a base function before any transformations have been applied. The parent functions with you should be familiar with are these ones. They're on that sheet I just did. X squared, root x, 1 over x, exponential. I did a 2 to the x on your sheet, but all of them look kind of the same. 2 to the x, 3 to the x, they just grow different shapes. And sine x, cos x, yes, for homework questions. Just me personally going, okay, even though it's in your homework, none of these on the test and so on until we do the trig chapter. And the new one, absolute value of x. So how many is there? 2, 4, 6 total. 5 old ones, 1 new one. In this lesson, we will consider several key properties that can be used to describe functions. To begin, consider the graph of a function f as shown above. Here's a function, and here's something you should be able to do with functions already. Another review of domain and range. You should be able to state what the domain and range of this thing is. So the domain is x elemental reals, and the lowest x is 2, and the highest x is 9. So we write x elemental reals such that 2 is less than x is less than 9. If you absolutely dislike this, I've got a new way. This is why I'm so glad that we got to this lesson today. There's another way to write this that is much simpler. It'll seem like completely weird when you first see it, but it's much simpler. You can literally just write the beginning x value and the ending x value. Let me do it. Boom. Just like that. I'm not quite done yet, but it's just like that. So instead of all this x elemental reals such that the less than's, all that kind of stuff, we're totally allowed to write 2, 9. Now, if it's less than or equal to's, we use a square bracket to let everybody know the 2 and the 9 are included. So that's the one new thing you got to learn, is that you use square brackets. But isn't that convenient? Instead of all this, lowest x, highest x, done. So convenient. But weird. You might think, well, won't this get confused with points? It actually never gets confused with points. Because a question will say a domain. Give me the domain. Well, you're not confused. It's not a point you're talking about. It's an interval you're talking about. Say, oh, graph the point 3, 6. You're not confused. It's not an interval. It's a point. So you'll always be able to figure out which one they mean. I'll use this all through this lesson, and you can switch over if you want. Yeah, yeah. And I'll do every kind of example before the lesson's out. So if you have more questions about this as we go along, that's fine. I think I'll answer them as we go, but that's fine. This one, range. Lowest y value, 1. Highest y value, 6. So it's range. This PowerPoint really good too, this video, for really showing domain and range. You can really see what we're talking about here. We're going from 1 to 6 here. So you could write it like that. But with the new way, you could go, okay, lowest y value, highest y value. Square brackets because there are equals there. Nice, huh? Yeah, why weren't we showing this before? We have this thought that grade 11's got enough problems without throwing in another whole new notation. Because we're not throwing this out. You have your choice what to use, but so does the textbook. So they might throw this one at you, and you got to understand it. When you write your answers, you can write them like this if you want. Questions? Intervals of increase and decrease. That's the next thing we might talk about when we talk about functions. We might say, where are they increasing? Where are they decreasing? So in form, we have function is increasing if it rises from left to right, and decreasing if it falls from left to right. Why do we do it that way? My grade 9s, I just got finished with the grade 9s. They're so funny. It's to try and explain this to them. Because I'll say, oh, between 2 and 4, it's going up. And they'll go, well, no, could be going down. I'm like, that's actually a pretty good question. Yeah, really, when you think about it. Why does it have to be left to right? And the answer is, because this axis is often time. You know, when you actually go to biology or you go to chemistry, you go to physics, this will be time or maybe number of something. So we'll be going left to right as things get bigger along here. And so we want to go left, right. Think about your bank account. If this is time, we want this to happen with your bank account, not this to happen. Yeah? So these are the increasing sections. These are the decreasing sections. So this function on here is increasing on the intervals. See, it increases between 2 and 4. And then it increases again between 5 and 7. And you could write it that way if you wanted. Or you could write this way. Watch this. 2, 4. But now, open brackets. These kind of brackets if you want to not include the endpoints. If you're saying, no, not at 2 and 4. And here, 5, 7. If this is completely weird and freaking you out, just let it grow on you. By the time you do a few of them, you're like, oh, I like this. Most people, by the end of the chapter, they say, no, I like this better than this. I was like, then you don't know enough about this. Once you get used to this, it's like bang, bang. You just write down lowest, highest, done. More. Where is this function decreasing? That's in the blue section. Between 4 and 5, function's decreasing. Between 7 and 9, it's decreasing. So this was 4 less than x less than 5. This was 7 less than x less than 9. You could write this as lowest, highest. Lowest, highest. If you don't want to include the endpoints, you use the circle brackets. If you do want to include the endpoints, you use the square brackets. That simple. Takes some getting used to. Do you have questions about increasing and decreasing? Do you have questions about this notation? It's good? All right. Okay, we don't really need this. I put it on there because this is the way textbooks talk sometimes. Formally, if a function's increasing, it means if you have smaller x values, you'll have smaller y values. That's all it's trying to say there. I don't want to get hung up on this. You know, I'll just mention it because sometimes you got to be able to read textbooks and understand what they're telling you. But all it's saying is, hey, listen, if you've got a function that's increasing, if you've got a lower x value, then you should have a lower y value if you're increasing. If you're decreasing, a lower x value will give you a bigger y value. That's all that it's saying there. But if you were good up till there, don't let that throw you off. That's just me nudging at formal stuff. Really, it's getting ready for calculus. Calculus has a lot of formal language in it. And so in advanced functions, we just try and creep up on the formal language a little bit. So when you get there, you're ready for it. I'm not going to put some crazy advanced function question test like using this kind of language here. I just want to introduce it to you. Absolute extreme values. Well, the absolute maximum function is its highest point. You see, someone might say this is a max point, and I agree. It is a maximum in this little section here, but this is the absolute maximum. It's the highest one going. Picture is sort of like a roller coaster. You know, I went to the biggest I've been on is Behemoth. But the Behemoth has got that first big hill. You go way up. And then it's got some other hills there. It's got some other max and mins, some other high points there, but there's only one that's the highest of the high. And someone says, well, what about sine and cosine? Sine and cosine have the same hills all the way through. They can all be absolute max, so you can have a tie. That's okay. But in this particular function, there's one that's the highest. It's an absolute maximum. So the function on the right has an absolute max at 7,6. The absolute min is the lowest point you see on the whole thing, and this is the lowest point we see on this whole thing. Its absolute min is at 2,1. Notice the absolute min doesn't have to be like a bump or a little hump like this. It can be maybe where the ride started. If we're going to continue with the roller coaster analogy, you could be at its lowest point there. And here's the formal thing. Formally, it's saying if something's an absolute max, at that a value, it's going to be greater than all the other x values. If it's an absolute min, it's going to be less than or equal to all the other x values. Do you have questions about absolute max and mins? It's just the highest point you're looking for. It's possible not to have a highest point. We just looked at 1 over x that went like this. This went straight up like this. Y equals x squared doesn't have an absolute maximum, so it's possible to say no absolute maximum. Local extreme values. Well, this is right here. There's a local extreme value. It's not the extreme value on the whole thing, like it's not the highest of the high, but it is a highest point in a certain little area. So take a look at this. If we just look in here, this is a maximum in that little section there. It's not the highest point of the whole function, but it is a local maximum, so we say there's a local maximum at 4,5. This one's a local minimum, 5,3. And there's another local maximum at 7,6. This is local, even though it's absolute. It's anytime you get to the high of a function, you're talking about a local max and min. And in this course, these ones will not be considered local max and mins. They'll be considered endpoints. Local max and mins are the times when you get the little bumps and humps. Do you have questions? Feels like I'm rushing, except the stuff here is all I've really talked about so far is when you're going up, you're increasing. When you're going down, you're decreasing. When you go from increasing to decreasing, that's a maximum. And the one that's the very highest is the absolute maximum. That could be the review of the whole lesson so far. Oh, and the more on this interval notation. When you go from 2 to 5 like this, you can now write it like this with square brackets. Why the square brackets here? If the equal signs are there, we use the square brackets. If the equal signs aren't there, we use the circle brackets. Like, that's weird, I don't like it. I know, at first it's like it's weird, I don't like it. Then you use it a few times, you're like, oh, it's so much faster. Woo. Lowest, highest, done. Oh, here's the formal thing. If you switch from increasing to decreasing, it's a maximum. If you switch from decreasing to increasing, it's a minimum. Take a look at this. Increasing, decreasing, that's a maximum. Decreasing, increasing, minimum. That's a real warm-up for calculus right there, let me tell you. That is like almost exactly what we do in lesson 1 of calculus. Increasing, decreasing, max. Decreasing, increasing, min. Doesn't seem so hard. Calculus isn't that hard, just lots of algebra. Questions there? Questions? No? Some examples. Take a look at this parabola. Hopefully, we're getting to the point where when you see that, you're sort of thinking, oh, this must be like a y equals x squared type of thing. In this case, a y equals negative x squared type of thing. It doesn't ask for the equation, but hopefully those connections are being made. Oh, well, hey, we're reviewing the whole day here. Perfect last few examples. From here to the end of the day, we're going to review everything we've talked about today. Domain. Any x values possible. When any x value is possible, we write x element of reals. Every y value is not possible here. You can't have y values above 4. The y values are 4 and less, and how do we write that? We write y element of reals such that y is less than or equal to 4. You're like, oh, well, what about the new notation? You got to write lowest, highest, and this one doesn't have a lowest and a highest. You can do it, actually. You can do it. What you do is you go, okay, I'll do this one first, the range. You could do the range as going, okay, Lowest possible y value, negative infinity. Highest possible y value, 4. Now look at this strange set of brackets I built here. Square bracket around the 4 because 4 is included. Circle bracket around the infinity. You can't include infinity. How do you? Infinity represents a bigger number than anything we can think of, so you can't include it ever. You're like, I don't like, okay, you almost had me convinced on this new notation, but now I don't like it for these ones. Okay, don't use it for these ones. Use the other one for the other ones. You know, you got your choice now. It's totally wide open, whichever way around you want to use it. Domain. All x values. How do you do the lowest and highest? Can someone land this thing? What lowest and highest values would I use if I wanted to go all real numbers? Yeah, so it's not that bad. You're just saying, okay, lowest is negative infinity, highest is positive infinity. Infinity is kind of, sort of a convenient thing there. Intervals of increase and decrease. Incidentally, on almost all my tests in this chapter, here's a giveaway for the test. On almost all my tests in this chapter, you'll see it's a handwritten function. Here's what I'll do. I'm totally giving it away. You can write this down. What I'll do is I'll take an axis like this, and I'll just photocopy it. And I'll ask these exact questions here. I'll say, tell me the domain, tell me the range, intervals of increase and decrease. Exactly what this question's asking here. And then right before the test, right before I photocopy the test, I'll go, what do I want here today? Maybe I'll have like a maximum there, and then a minimum there, and then a maximum there, and then like that. And maybe I'll ask them about what the absolute maximum is. You know, maybe I'll ask about the intervals of increase and decrease. You know, and then I'll ask, this is my tough question here coming, the absolute min. And the answer is none. There's no absolute min here. Yeah? So that's totally given away. When I go to photocopy this blank, and then I just draw one in there and go, okay, give me all these answers. Because I ask that question every year. This question right here, I asked that. So you can put a big red star there going, this is coming. Here's 3 or 4 marks right here. It's just being able to identify all this stuff. So interval of increase, this thing is increasing over there. This is a little weird how we write this. If it's increasing over there, what we're talking about is all the x values that are less than 2. And are less than negative 2, sorry. And that messes people up. Because when it says x less than negative 2, your brain goes, look this way. It's just something about the x less than negative 2 that tells you to look over here like this, and you go, well, no, it's decreasing there if I go right to left. Yeah? This causes your brain to flip over and go, oh, look right to left. No, we're always left to right. We always go left to right because this axis, when you actually go to do this stuff in another course, biology, chemistry, physics, economics, any of those courses, this axis has a great chance at being time. And that's why we always go left to right, because time goes left to right. Time gets bigger and bigger and bigger all the time. So don't let a notation like this, x less than negative 2, mess you up. Say, and let your brain start going right to left. What you're saying is, okay, when is this increasing? When the x values are less than negative 2. And you saw my hand just do it. Go like this, right to left. You almost need your other arm on the page going, okay, increasing, the x values are less than negative 2. Weird. Only happens with that less than. The greater than works out good. Where is it decreasing? It's decreasing over here. Notice the great animations in this PowerPoint. This stuff's messing you up tonight. Just watch these videos again, or just watch the PowerPoint, because it really shows what are we talking about here. It's decreasing over here for x values now greater than negative 2. What about at negative 2? Why is at negative 2 not included in either side? What's happening at negative 2? Yeah, well, it's the maximum, so it's not increasing or decreasing there. It's sort of stationary for a moment. It sort of stops there at the top. Okay, if you want to write these in the new notation, x less than negative 2, you'd go from negative infinity up to negative 2. And for decreasing, you'd go from negative 2 up to positive infinity. And again, I'm not trying to sell the new notation. I'm really not. You got your choice between the two, depending on what's best for you. Absolute maximum value. Not too bad, not too tough a question. Absolute max, right there. F at -2 equals 4. That's where the absolute max value is. Absolute minimum value. Here's me hesitating. Because in the middle of all these infinities, every once in a while someone on a test will say, absolute minimum's infinity. I know why you're saying that. I know why people think that. Is because you go, oh, you're just using the infinities. Can't I just use infinity there? But you can't have a minimum value. You can't go, oh, my lowest value is infinity. Infinity is not a number. It's an idea. And in fact, there's whole books on the idea of infinity. And I can tell you this book is incomplete. It goes on and on and on, like on and on and on about infinity. Infinity is a big problem. So for us, we've got to be careful with infinity. Very, very, very careful. Infinity is this idea that it gets really, really big. Bigger than anything we could talk about. And in here, it's simpler than that. Minimum value doesn't have a minimum value. There's no spot here where we go, okay, that's as low as we can go. Okay? Local max, there's only one local max right there at -2, 4. My son's name's Max, by the way. Somebody said to me one time during summer school, Mr. Todd, did you name your son after a math term? And I was like, I don't think so. Not that I know of. And then it was a couple years later, I was calling him from across the parking lot. And I said, Maximum, let's go. As I said it, I'm like, oh no, maybe I did. So I was very careful with the next two kids, Chloe and Bennett. I don't think there's any way to screw those two up and say it's a math term. Say it again? Yeah. If there's other local minimums, you just make a list of them there. You could have multiple local minimums and local maximums. You can have multiple absolutes as well. Think of sine and cosine again. There's lots of absolute maximins and lots of local maximins. Yeah? There's no local minimums here. This is probably closer to the thing I'll choose for the test, so let's go through that carefully. Incidentally, I don't really care about that clock. I don't really care about that schedule. Having not been through this with me once, I just did it a whole quadmester with another class. When things go wrong, when we lose half an hour because of I have to do some extra explanations, or we lose an hour because of somebody comes in and wants to do a presentation, or whatever happens, I'll just modify the schedule and we'll get it worked out, okay? So never panic and go, Mr. Todd, hurry up. Da-da-da. No. I'm going to carefully make sure I explain these things the best way I can with your input all the way, nodding, shaking your head, so I know I've done a good job. Here, test question coming up. Yeah, go back to this video and watch this. This is close to exactly the type I'll choose. Maybe I'll choose one like that instead. Maybe like this. Domain, you got to be able to get the domain and say, okay, the x values keep going on either side here, x element of reals. Great animation here. If you're still having trouble with these ideas, go back and watch these animations. They really show what's going on. Range. All these y values are available. All these y values. All the y values are available. Y element of reals. Intervals of increase. Okay, you really got to be careful. And on a test, you might want to take your highlighter out and go increasing here and increasing there and just light those up. So you're like, okay, I see where it's increasing. Always left to right. So it's increasing in there for x less than -2, and it's increasing in there for x greater than 2. Where is it decreasing? Right in the middle there, between -2 and 2. Absolute max value. What's the highest number you can get to here? There isn't one. There is no absolute max here. Absolute min, also none. Now you see why I usually choose one like that. So that it does have an absolute max and doesn't have an absolute min. I get to test everything in one question. Yeah? And say, oh, Mr. Todd, I'm going to take a picture of that on the way out. Sure seems like he's going to draw one like this come test time. It certainly feels that way. Local max value. There it is. any little bumps or humps. Those are the like little tops of parabolas that if you want. G at negative 2 is 4. And a local minimum value, there's one right there. G at 2 equals negative 4. Any questions about this thing? Yeah. So we could, x less than negative 2, we could go negative infinity up to negative 2. Open brackets, you can't include negative infinity. We're not going to include negative 2. And you could go 2 comma infinity. And between negative 2 and 2, you could just go negative 2, 2, like that. So this is a little nicer for these type of things. But the infinities bail you out here. You know, to say, okay, all the way down to negative infinity. It seems weird that I can use infinity here, but I can't use it there. But because this is an interval, I'm just saying, where do I go to? I go out to negative infinity. Here it's saying local minimum. It's saying an absolute minimum. What's the lowest value? There isn't one. This one, no, because it's not less than or equal to. If they were less than or equal to, that's when you start using the square brackets, like this one here. Yeah? Other questions? Another example. I've got to watch when we switch over to the worksheets here. Oh, yeah. Yeah, and we're never going to make it. Never are we going to be able to finish this lesson. So tonight you'll do page 11. You'll do page 16. Hopefully you'll knock down some reviewing the basics. There's still lots for you to do. You won't run out, will you? Yeah? And like I say, if every day you're falling just a little bit behind, Wednesday's your big recovery day. You know, because I'm going to teach a very quick lesson Wednesday morning at 9. Probably wrap it up by 9:45, 9:50. And then you've got over 5 hours in class to pull this all back together with review and practice tests. So I'm not saying, oh, you know what, I'm going to take the whole night off because I got all Wednesday. That's stupid. That's stupid. Yeah? But when that panic feeling starts coming, you start doing the bunny run out the room thing, you go, oh, you know what, I just got to be close. As long as I can keep this race close, I can make my big comeback on Wednesday. Yeah? And Thursday. I'm only teaching one lesson Thursday, and we'll write the test in the afternoon. I do have one more trick up my sleeve if we need it. I can modify one more. I can buy you one more evening, but you biology people aren't going to like what I do because it downloads a lot of homework into your other quad or your other week. Wait a minute. This feels like the worksheet to me. Is it? Am I right? So switch over to the next page which says properties of function lesson worksheet to do this example. We might get through one of these, making it so you could do a little bit of this homework tonight if you wanted to. That's all I'm going to do. I'm going to do one example, and I'm going to pause the video there and write down the homework. Good. These are weird, except they're pretty easy after you see a few of them. So there's a few attached in the homework. Instead of just textbook homework, some of these are in your sheets there. If you flip ahead a couple more sheets, what does it say? Somewhere it says, assigned work. You see the words assigned work? This is homework outside of the textbook because we often thought the textbook didn't cover these things well enough. Didn't give you quite enough work there. Thank you for the extra work, Mr. Todd. Why, that's so kind of you. You'll think it's kind when you're writing the test and you know how to do them, won't you? Yeah, all right. Graph this function that has all the following properties. F at 1 equals 2. Nothing weird about that. That's saying when the x is 1, the y is 2. Boom. I'm well on my way to graphing this thing. I don't know everything about this, but I do know there's a point at 1, 2. There's also a point f at 3 equals 0. There's a point 3, 0. And also f at negative 1 is 0. So there's these two other points I can use. 3, 0 and negative 1, 0. So when they list function values like that, they're giving you points. And points really help when you're graphing. In fact, I already sort of think I see what the graph's going to look like here. Not maybe the whole thing, but I sort of see, oh, it's going to go, I don't know what the rest of it does, but I sort of got a feel already of what this graph's going to look like. Oh, there's one more point. F at 0 equals 4. Also a point. Let me write that on there. Now I really can see what I think the function's going to do. At least most of it. It's going to go here. It's going to go up to there, down to there, through here, and then I don't know what it's going to do after that. I need some more information. This is the tough part here. We'll take a couple minutes talking about what this is saying. It says f at x is greater than 0 when x is less than negative 1. And this is where switching between function notation and xy notation really helps. Because you go, oh, f at x, you mean y. The y values will be greater than 0 when the x value is less than negative 1. So when I'm looking over here, in this section right here, when x is less than negative 1, the y values will be greater than 0. Now, I don't know if I'm doing this right or not. But I do know this function has to be greater than 0 somehow. And you get some openness on these type of questions where you go, oh, it looks something like that. I fit the qualification there. It's greater than 0. Have I fit all the qualifications that come later? I don't know. I won't find out until I finish reading. So for now, I draw that on there and I go, okay, greater than 0. It's right. So far, everything is right. It says f at x is less than 0 for x greater than 3. So in this section, it says your y values have to be less than 0 when the x values are greater than 3. So when you're over here, we need y values less than 0. And I'm not going to be quite so dramatic this time. I'm just going to go, oh, maybe it's like that. I don't know. I just have to fit the qualifications that's in there. Could somebody have given a different answer? Could someone else have gone, oh, like this? Or yeah, as long as they stay less than 0, it's right. You're like, well, how do we actually know? Without an equation, we don't actually know. We just know sort of the shape here, that's all. Domain x element of reals. Okay, yeah, I got that. X element of reals. I guess I got to connect these up now. Some people will be bothered by the freedom of this. You're like, so I can just do whatever I want? Yes, as long as it does these things. So lots of choices as long as you do the things it says on the thing. So I got the right domain. Do you agree? I now x element of reals. Now, y, oh, between negative 4 and 4. I have to stay between negative 4 and 4. Difficult when you first see it. I broke the rule here. Can you see? I did here? Ah, no good. So I got to fix that. Between negative 4 and 4. So the way I'm going to handle that, and there's multiple ways to handle it, is I'm going to go up to a maximum, and then I'm going to sort of settle in like this. I'm going to stay above 0, but I'm going to have this maximum here. You're like, so you just do whatever you want? No, not whatever I want. I just have to do something that fits within the qualifications given, and it said stay between negative 4 and 4, including 4. Somebody else goes, well, you included 4 over here. You don't have to go all the way up there. I'm like, well, yeah, I don't have to. I have another choice then. You could go much simpler than all this. You could just say, okay, all I'm going to do is go like that or something like that. Yeah, lots of choices over there as long as you stay between negative 4 and 4. Did I break the rule somewhere else? I didn't know I was breaking the rule when I first did it. It's only later I find out, oh no, you're supposed to stick between negative 4 and 4. So I get rid of all this and I go, okay. Pen, I'm going to decide it goes down to negative 4 like this, and then I'm just going to go settle in like this. Lots of choices there. It's not like you're doing anything you want. That's what people feel like sometimes, like, so I get to do whatever I want? No, not whatever you want. You got to fit all these qualifications, but you do have some openness in how you handle that exactly. Questions about that? Yeah, I had to include 4 and negative 4 there. I was lucky 4 was already included here. Here I went down and made sure I included negative 4 because it said include negative 4 in there. Little detail there that you got to watch out for.